Welcome. In this video I'm going to show you how to develop a compound miter. So it's a sloped radius, a sloped mitered wall. Could be sloped bevel, but in this case it's bevel would just be one side, and then the sloped miter is the two sides. So what you're going to do is you're going to draw, in this case, let's go back. I want to show you in this case, we have some actual size of it, right? But in the formula, if you're just looking for the angles, you can leave this, everything as one, like a one thickness and one, so it'd be a 1 by 1 by 1 in the thickness and depth and height. If you want, like, it's pretty convenient to have this dimension here. So like if it was 10 tall and 1 thick, it'd be kind of nice to have the 1.8257 right here, so you could go 10 by that dimension there, and you would have the angle instead of just the angle, because then most people don't know how to convert an angle to a rise and run. But if you had a 10, the height of your wall, or not the height, but the diagonal, the actual wall panel itself was 10, you could put in that dimension 1.8257. Let me zoom in a little better. And then that would be this dimension here. And that would be that angle right there. Right, so you'd have the rise and the run. Text same as. Doesn't look like that's broken, does it? It looks huge. 1.8257. Let's take that to a 0.5. Enter. So let's get rid of that, and then you would have the rise and the run. And that's pretty convenient. So, but if you're just looking for the angles, you can use everything as one. But in this case, it's not. So it's a little easier to show you. Just show you on this one here. Okay, so you have a wall panel that's 1 thick and 10 long. The height would be relative to that. It would be, so there would be your height. So what we need to do is we need to find this. If we project it up into a plan view, this is a plan view of that panel here, and then this one is this one here, and they're joining together at a miter angle of 120 degrees inside angle. So we know that the spring angle on this, in this case, it was the spring angle just means it's off the vertical, and you could do the arctangent of 2 divided by 6, and you would end up with 18.4349. So what we do to find this angle is we're going to type in x over 10 is the sine of that angle. So tools, calculator, x divided by 10 equals sine of 18.4349, close parenthesis. And then we're looking at this, 10's on the bottom. We want x equals, so 10 is going to be multiplied times 10 times 10. Let's just get rid of that. Delete. And then we'll end up with this number here, 3.1623. And then the same thing is over here, except that since it's 90 degrees over, it would be the sine of, let's just make it the cosine right here, alt MA. Doesn't look right. That angle, we'll use the same angle, out and A, and we'll use the cosine. So that angle and that angle are the same. Delete, and then what we're going to do is going to zoom in here, H, K, enter, and then this dimension here is going to be, freeform is 0.9, like we got there, 0.9487. So what we're going to do for that one is tools, calculator, and the thickness is 1, right? Right there is 1. So x over 1 is the cosine of that angle. So x over 1 is equal to cosine of 18.4 close 4349, and then we want 1 is going to go under the top, so that's it, backspace, it's times 1. Going to end up with 0.9487. Okay, so that's where those two come from. And then we go move those up to here. That dimension there is the 948. This dimension here is the 3162 right there. So we know this angle is 60 right there, 60, that's also 60. So we know this is 3, so 3.16 over x. We don't know this one yet. So this is x. So 3.16 over x is equal to the tangent of 60. So 3.1623 divided by x equals tangent of 60. Right, so that was divided by, right? So this is on top, the x goes to the top, the tangent goes to the bottom, so delete, 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 divided by, we'll end up with that, 1.8257. So that's how you get that dimension. And I only put it there because it's less crowded, but it's actually the same as this dimension here, so let's just get rid of that. And it's the same over here. We're going to do the same thing. So this is same formula. So we can just do the same thing. Tools, calculator. We can go tangent of 60 equals 0.9487 divided by x. And then we just move the x to the top. Tangent goes to the bottom. Back. Divided by tangent of 60. Get rid of that. Back. Enter. And end up with 0.5477. That's how you get them. Close. I don't know if I'm going to walk through every single one like that, but so now we got zoom in here. Let's pull back a little bit. This is being projected perpendicular to this line here, right? So then we've got this is the 1 inch thick, and it's opened up towards us, so it's flat facing us. And this is the 10, and it's facing towards us too, perpendicular to the plane. So we have this. What we need to do is project it up to there. All right, so let's zoom in there. That's the 0.5477. So V, like that, right? We're going to project it up to that edge. So we can see what we're going to do is we're going to fold this plane away so that it'll be hidden behind this line. Right? But this needs to be there, right? So that's good. Now we know where this bevel is going to be, except the bevel needs to be perpendicular to this line to get an actual measurement of an angle. It's too skewed to get an accurate reading. So we know this distance is 0.5477, and what we need to know is what's that perpendicular to these lines are. Yeah, so the way we do that, we know this is 10. We got this is 1.8257 tools. Let's go tangent, atan, 1.8257 divided by 10, close parenthesis, and we'll end up with 10.346. 10.346. I think I got rid of it somehow. Out then A, right there. 10.346, 3465. It's just a little error because we're using math, not carrying that out too far. So that's the angle there. So we notice that since this is the angle of this triangle, this angle here is also going to be 10.3468 out and A. Right? So there's that little triangle in there, and what we're looking for is this. Let's say that's X. What the heck? Delete TX. Sometimes it does that. Looking for that little thing here. We have this dimension. So that dimension is 0.5477. So X over 0.54 is cosine of 10. So X divided by 0.5477 is equal to the cosine of 10 point. Actually, I already had it there, didn't I, from the previous calculation? So we can close that, and we're just going to leave the X there, and we're going to cut this and multiply it to this side, and get rid of that. X equals cosine of 10 point whatever times 0.5477. We're going to hit compute, and that'll give us the compute. I think I missed the decimal place. Let's see, so cosine of 10.3468 close parenthesis is equal to X divided by 0.5477, and then we're going to take that, multiply the times 0.5, must have missed a decimal place, 5477, delete, and that'll give us the 0.5388. 0.5388, that's how you get that. And then so now we have, that's the 0.53. What we can do is that is going to be projected up to I don't know what kind of, it's almost like a wormhole view of this panel from the side, looking at it in this direction. Right, so now we're looking at we're going to change it by opening this panel up this degree, up the same out MA is going to be the same 10 degrees, 10 point whatever degrees. Now we're looking at it from that direction, so we're looking at it in line with that bevel cut, right? And that's going to give us a true degree of that bevel, so that the saw being beveled at that angle is going to be right on that in that line there. That angle will be the true bevel cut, and then the plate angle, the miter angle, would be this angle, and this will be the bevel cut. So we're going to take this, so arctangent atan, and it's going to be this divided by the thickness is 1, close parenthesis, and that'll give us this 28.31. Compute 28.31, and that's how you get to that. So we've done all the steps there, which is, that is one gigantic arrow. Let's move on to here now. So did both. I did a 90-degree open angle and another open angle. This is the one we just did. So let's just do that, because really the same thing pertains to all these, except I didn't put thickness in. It was just a spring angle and included angle. But let's do this, since we have the thickness, the thickness and the width, or the height, then that's a good word, thickness, and length of panel, or the width of the panel, and then the spring angle. And in this case I just did the same spring angle. It was 1/4 or 1/3. Let's see, it was 1/3, 20 divided by 60. That was 2 divided by 6. Plan angle is 120, miter angle is 60. So that's just this divided by 2. So then we have the same calculations we did before. Times B31 times 10. So that's how you're going to get that 3.16. It's a lot more complicated in the formula, but it's pretty straightforward. You're just looking for the sine of the angle here times the 10, like we got right there. Just moving that around, so get rid of that. Equals, so equals, so it would be sine of B32, close parentheses, times B31. There you go. Same thing here, except I think it's cosine, right? So this 0.9, like we did before, it was the cosine, so you end up with cosine radians, B32 times B30, which is the thickness. B30, which is the thickness. So let's go here to the 0.45477. Then we did that one too, and it was from before. So this is the tangent of 60 is equal to 0.9, this thickness, right? We're looking at that little, zoom into that little spot right there. We're looking for that x, 0.54, right? So 60 is right here, this angle. So this x, so we're looking at this. We're looking at the tangent. We have this one. We're looking for this one. So 0.948. So the arctangent of 0.948 divided by x. The tangent of 60 is 0.948 over 6x. And then you solve for x. You get 0.54. And then we have this jumpy thing. So we have similar here. We just did that. It was x. So it'd be 3.16, this dimension, divided by x equals tangent of 60. 3.14x divided by x equals tangent of 60, and then you solve for x, you get 1.82. That's that dimension there, and then you have a tangent cut. You can just give that dimension on that panel for the plan cut, or the angle if you're on a miter saw. If it's on a big panel, it would be 1.8257, and then the run would be, that would be the rise, and the run would be 10. And you can solve for the arctangent to those two, and you'll get 10.346. So you have the angle 2. Then the plate angle, the actual, what's the plate angle? I don't know why I did that. And then the dihedral angle. Boy, zippy, man, get a headache. Frickin' thing jumps around. So that is the plate angle. That's our 10, plate angle is there. And then x of cosine, this is 28, this is the dihedral angle. Or a bevel cut. that's it. So then you can run through, check those. So we can change these dimensions to 110. So if that was 38, enter, and 120, you can look at those two dimensions there, those two angles, and check it against one of the charts. I think there's a chart here. Here we go, 90 degrees or 120 degrees. Oh, it ends right there, 119. Let's go 119. Did we get, check that. And the spring angle, I think the spring angle is probably 52.38. 1993 and 23.57. So the nice thing about this is you're not restricted to whatever. You can do your own, depending on if it's a custom spring angle or a custom wall. That's how you do develop a compound miter angle using the compass. So if you're like cutting a large panel, you would know across the long side what the angle is. Like if it's a 4x8 sheet of plywood, you could go let's do that. Let's make it a 48 for the width, 48, enter, and then you would know spring angle's 38, right? Thickness is say 0.75, and plan angle 119. Let's go 120. Miter angle is 60, so that's just that divided by 2. And then this here would be the 19.56. But what we could do, you could actually put in the dimension of this would be so x divided by 48 equals tangent of 19.57. So we don't know what how much to cut off one side of the 4x8 sheet to get that angle, and using that we would go tangent of this. So equals tangent radians open parenthesis 19 this close times 48, enter. And then you would get 17. So let's go 17.06. Let's copy that. Let's just open it up on the side. So we're going to make a 4x8 sheet. Come on, really? So we get 17.06171113, enter, alt and A. We get text larger is what we get. So we get 19.56. 19.5678, 79. There you go. So that's how you would get, like if you had that angle there, on a wall cut, it's not the greatest. You would want to have that cut for, so you'd know the tangent cut for the long side. You're not going to fit that in a chop saw. So I hope that helps you get to understand and possibly use that in your career. It's a lot of information for one video, but I hope that helps you, and thanks for watching.